right, well hello, I'm Mrs. Cresswell. I teach agriculture at the Upper Sandusky High School. I teach the FFA program, and I have with me today
I'm Kim Harvey. I teach 6th grade science in Cardington, FFA alumni and proud supporter.
So today we're going to show you a little bit about what to do if you want to do a stream study. I know one of the courses I teach in my class is water quality, and in order to determine water quality, one of the best ways to do it is to see what's living in the stream or creek that you have nearby. So what we're going to be looking at today is the Sandusky River, and we are at Stepping Stones Park here in Upper Sandusky. It's called Stepping Stones because the Wyandot Indians actually had stones that they put across the river to get from bank to bank when they had their reservation here. This was the last Wyandot Indian reservation in Ohio. So the Sandusky River flows north into Lake Erie. We have two major watersheds in Ohio, one being the water that runs down into the Mississippi River into the Gulf of Mexico. And then we have the rivers here in the northwest part of Ohio and northern Ohio that flow into Lake Erie. So State Route 309, which a lot of you are familiar with, is pretty close to what we call the divide in Ohio. It divides the waters that flow south with the waters that flow north. So Upper Sandusky is called Upper Sandusky because we are upriver from Sandusky. So a lot of people are always confused. They think Upper Sandusky is north, when in reality our river flows north and we are upriver. So this is the Sandusky River. We're going to be doing a water quality test on today. All right, so in order to determine water quality, we have to look for the organisms that live in the water. They're going to live here full time. So if there's any amount of pollution, the very sensitive ones are going to disappear first. And so we want to look in the areas of the stream that are the most sensitive, which are going to be the riffle areas. So within a stream, you have smooth water and deeper water that are pools, and then you have this kind of white watery type water that are your riffles. Higher in oxygen, better for predators, and so this is where we're going to look for our organisms at. And you can see that Kim down here has got a seine. This is what we're going to use to catch the organisms with. It has really, really small openings because these macroinvertebrates that we're going to be catching are really tiny. So I'm at the top of the riffle, Kim's at the bottom of the riffle, and we're going to kick through here. It's called kick seining. We're going to kick through the rocks and the sand and the pebbles that are on the substratum here to have then the organisms flow into the net to see what we can catch. When you kick seine, you just want to go in and you want to stir up all the gravel so it goes right into the net. Usually you have multiple people that do this and nothing can get away. So all the rocks, you want to disturb their habitat. And when you get to the end, then you can see what you have. Okay, let's take that now. You got it?
Yep.
All right.
Since I work with 6th graders, I have a simplified version of the paperwork that is used with older kids that help us to sort the macroinvertebrates that we have found into these 3 groups based on water quality. The macroinvertebrates that are down here in group 3 can live in a pretty polluted body of water. The macroinvertebrates in group 2 need their water to be a little cleaner. And if we're finding animals that that are in group 3, those live in really clean water. So this is what we're hoping to find, is a lot of macroinvertebrates from this area. Now, what we see Mrs. Cresswell doing is looking through here, and she is dropping them into these tubs that are labeled as 1, 2, and 3. So if we know what they are right away, we can go ahead and start sorting them by their taxa group, get them back in the water so we can take a closer look and look at our numbers. If we're not sure, there's one with a question mark, and then we can take a little closer look at some of our photos and our examples that we brought with us to identify those macroinvertebrates. What's this little guy? This looks like it might be a mayfly.
Yeah, there's a lot of these gotta all be riffle beetles.
I think that's a mayfly.
Yeah, put him in one, and if he's wrong, I'll move him out.
He was small, so I couldn't see his tail feathers.
Yeah, that's why you gotta get them in the water, and then they're easier to see their tail.
Okay, as you can see, there's a 3 on the bottom of this container, and these are in taxa 3. These are animals that are going to be very tolerant to pollution. So we have aquatic worms. These are not the ones that you would find in the soil. They look a lot like our worms that we see when we're digging in the garden or in the field, but these are going to live in water. And we see planaria worms here, and if you take a look there, you can see that there's a little arrow-shaped head and tiny little eye spots there. Not that they have vision, but they're sensitive to light and dark, so they can tell whether they're in or out. They have a little feeding tube on their belly, like kind of looks like a little elephant's trunk, and they're going to eat a lot of the dead stuff that's in the water. But these little guys, you'll find snails in a couple of different groups because there are 2 different kinds of snails. If you hold it up this way, point up. A little hard to see that the opening is on the left. So this is a pouch snail. This is one that is very tolerant to living in polluted water. If its opening was on the right, then it would need a cleaner environment. So I'm gonna drop that back in there. So if we only found these guys, you'd probably want to get out of that water and look into what we can do to help that environment, because it is very polluted. But these are not the only macroinvertebrates that we found today.
So the class 3, you're going to find them even if the water's really, really good. So like we were saying, if this is all you found, that's a problem. But if the water's really good, you're still going to find these guys. So that's what you're taking a look at. And there's some other ones that are in group 3, but these are the ones we found today. Group 2 taxa, so these are going to be able to live in intermediate water, so they can live in good water and they can live in intermediate. So we have some things that kind of look like worms, but this is a crane fly larva. And I think it's really unique. Everybody always wondered, well, what in the world are crane flies? Well, this is eventually going to hatch out into those big mosquito-y looking type things that fly around that actually are not mosquitoes. People think they're giant mosquitoes, but they actually eat mosquitoes. So this is a crane fly larvae, and it's amazing this ugly, nasty thing can hatch into something that's so delicate like a crane fly. So those will probably hatch yet this fall with as large as they are. We have clams. To count a clam, you have to make sure that it's actually alive. And these are tiny little fingernail clams. You can tell that the shell is shut. And if I would try to force it open, I probably couldn't, or I would break it and kill the clam. So that clam is counted because he is alive. There is a clam shell in here. That's just half of it. We can't count that because it's not living. The other neat critter that we have is this dragonfly larvae. Some of these different dragonfly species can live 5-6 years in the water before they finally crawl up out of the water, and they'll hatch just like a cicada does. They'll hatch into the dragonflies that you see flying around the water. These guys are predators. They eat mosquito larvae, they eat all different types of things. If you get a larger one, you'll be able to actually see his mouth will open up right there, and he can actually grab his food and bring it into his mouth to eat it. So this guy still has quite a few years left in the water, but that's a dragonfly larvae. And that's what we have in group 2 from the looks of it. These are our group 1 taxa. These are the really cool ones to find. And we found some interesting ones today. So as you take a look in here, you can see things are kind of moving around. They're settling on the snails that are in there, so you have to stir them up a little bit. But right here we have a mayfly. You can see them moving around. Mayflies, there's a lot of different species, but they're easy to identify because they have 3 tails. And the way I remember that is the word may is spelled M-A-Y, has 3 letters in it, and so the mayfly itself has 3 tails. There are some other macroinvertebrates you're going to find, like the stonefly. We didn't find one today, but it can look similar. It only has 2 tails when it spreads it out. Now this mayfly, you might say, oh, I only count 2 tails. Well, he lost a tail. And there is one species of mayfly that does only have 2, so that does make it a little more difficult. But you can tell by how they swim, too, that they are mayflies. Mayflies usually live less than 24 hours after they hatch out, and a lot of the species don't even eat. They reproduce and die. We talked about snails in group 3. This is what we call a good water quality snail. If you hold it with the point up, you can see the opening is on the right. So this snail breathes with gills, and because it breathes with gills, it's a lot more sensitive to pollution, whereas those pouch snails in 3 don't have gills, and so they're able to withstand the pollutants. We have caddisflies. They kind of curl up into a C when you put them on your hand, and that's how I remember it. Caddisflies curl up into C's because there are beetle larvae that also look like caddisflies. These guys can build their own homes out of sticks, leaves, pieces of gravel. The ones we have here are the free swimming ones. They can be different colors. Sometimes in the fall we find green ones, but this is your caddisfly larvae. Most of these things we find in the water are going to eventually hatch out and fly around in the air, and caddisflies will do that. One of the few adults we find in the water are these little guys right here. This is a riffle beetle, and this is all the bigger they get. They are an adult, and it's kind of hard sometimes to tell if you have a riffle beetle or a beetle that fell in from the trees, and you have to look. Does he look like he's at home in the water, or does he look like he's drowning? This one's definitely at home. He's happy being down there moving around, so that's a riffle beetle. And then our most favorite one. You want to talk about the water penny?
Oh, go right ahead.
He's pretty cool.
He is. Looks like a little turtle shell.
So this is a water penny. They can get a little larger. They're called water pennies because they're circular and copper colored. When you flip him over is when you actually see, and you won't be able to see because he's so tiny, but he's got his little legs and everything underneath there. And he is a beetle larva. Eventually he's going to hatch out into a beetle. But these guys will stay suctioned to the bottom of rocks, and when you put them on your finger, you can feel their little feet moving on your finger, moving along as they start to crawl around, kind of like a horseshoe crab does. So kind of a neat little animal that we have there. Now we call all these macroinvertebrates because they're invertebrates, they don't have backbones, and they're macros, so we can see them. Microinvertebrates would be tiny, we wouldn't be able to see them, but this is what we're going to be looking at. These guys can't move very far, unlike fish that can swim from place to place if there's pollution, or other, like your salamanders, they can move, your turtles. So that's why we look at these guys, because they are living in the water on a day-to-day basis, and they have to put up with the quality that's there. So what we find is going to determine what the average water quality is in that section of stream that we're testing. Some problems sometimes with doing chemical tests. First off, operator error. You might make a mistake doing the test. And so if you actually look at the macroinvertebrates that are in the water, they're not going to lie because they have to live there. But we do the test to compare. Another error can be is this test is only testing the split second that you dip down into the water to take a sample, and then that water is already down river. And so maybe the second you tested it was good, but 5 minutes later there was something that came through that was bad water, and your macroinvertebrates are going to show that. A lot of times I do stream study in the fall. In the fall sometimes the water tests pretty good chemically, but then when we look at the macroinvertebrates we find there, you can't find anything. And it's because people aren't fertilizing their lawns in the fall. There's sometimes not as much water flow, and so sometimes that can be better or worse. And so we like to compare both of them. So there's different companies that have test kits. I use Lamont. It's just something I've always used. I like them. There's Hawk systems, there's other types, but they're pretty easy to use. And so first test we're going to do is pH. pH is a test of acid and alkalinity. And so it's a basic color test. There's instructions in here. It tells you exactly what you need to do for your particular test. Now, here in Northwest Ohio, our substrate is limestone. So we tend to have fairly alkaline water. And so when you get to other parts of the state, especially if you're down in the southeast or the southwest, you might find some acidic water because some of the coal mining, the acid mine drainage. So we're going to take this and we're going to fill it up based on what our instructions tell us, that I need to fill this up to the 10 milliliter line. Always takes a few tries. This pH range goes from 5 to 10. pH scale ranges 0 to 14, with 7 being neutral. And so we're going to then add 8 drops of our indicator solution. cap and invert it. And now we're going to compare our color to see what our pH is. If you hold it up to the sun, you can see the different range there, and as we take a look, based on what color your eyes are seeing, I'd say we're somewhere in between a 7.5 and an 8. So we're just a little on the alkaline side, which is what we usually test in our rivers around here. So the pH test that we did is important because if you have really acid water or if you have really alkaline water, it can affect the reproduction of your organisms and also affect their gills. So the next test we're going to do is the dissolved oxygen test. So all of our organisms, macroinvertebrates that live down in the water, they're going to breathe using dissolved oxygen. And we're looking for more than like 4 parts per million, 5 parts per million. Even that low, they're going to have difficult breathing. So we're testing here in the riffle area, which should have slightly higher dissolved oxygen, but we want to kind of see where we're at this point. So again, I'm using a Lamont test kit, and the instructions on this one are pretty specific because you have to fix the oxygen that's dissolved in the water and not let it interact with the atmospheric oxygen. So to get our sample, we're going to cap our bottle, we're going to submerge it into the water, take our cap off while it's underwater, has to fill completely. And then cap it before you bring it out of the water. This way you don't get any of the atmospheric oxygen that's going to be in it. Now we have to go about fixing the oxygen. So we have 2 different chemicals that we're going to drop in here to fix it, and we're going to get a precipitate that forms. I call those floaties. So we're using manganese sulfate and an alkaline potassium. This test kit calls for 8 drops of each. We're going to cap it and invert it. You can see there's a precipitate that's formed in the bottle. Want to mix the chemicals. And we're going to wait for this precipitate to settle down below the neck of the bottle. Depending on how much oxygen you have in there, that might take a little bit of time. So I'll let that sit. Settling. Those are nasty floaties. Once it settles below the rim, we're now going to add some sulfuric acid to break it up. You see that's going to start to dissolve the precipitate. See, it's starting to look clear as it dissolves it. And unfortunately we have to now shake this until all of that dissolves, which sometimes can take a really long time, because you end up with little brown floaties in that also have to be dissolved. Once you have this step done, then your oxygen is fixed, and we could go back into the classroom and we could test it, or we could do it right here in the field. I think I have it. Sometimes it takes really long. Now we're going to use our sample bottle. And I need to fill it to the 20 milliliter line. I've made enough sample here to be able to do this twice in case I mess up the first time. So now we're going to titrate this solution, and we want to titrate it to pale yellow. So we're going to use sodium thiosulfate to do that. Depending how much we put in, it's going to determine where our oxygen levels are. So you're going to pull the thiosulfate out to a marked level. Just a air bubble in there. And this is where it's important to use a white background, because as we drop the thiosulfate in, we're going to swirl it and we want to see it change color. So I'm going to put a couple drops in. And you can see it's already starting to turn a paler yellow than what it was. We don't want it to go clear. If it goes clear, we have to start over again. So you just have to gauge it to make sure, okay, is one more drop going to make it go clear? I don't want to get to that point. Still fairly yellow. And one or two more drops. So now I have a pale yellow. I think we can do one more. Now we're going to put a starch indicator in, which is going to turn it blue. And we're going to titrate this to clear. So this is all chemistry. Swirl that around, get a blue-purple color, and we want to go just to clear. If we run out of thiosulfate, we can fill it again. We just have to remember to add 10 to whatever we use. You see how quick it can sometimes turn. So we're using different chemicals in order to indicate what our levels are. Pretty fascinating, really. And this is another reason you use this white background. You can see that last drop is indicated turned us clear. So what we're going to do is we're now going to read our lines on here, and the amount of thiosulfate that I used indicates my parts per million of oxygen. So you can see that I used between 6 and 7. Each graduation is a 0.2, so I used about 6.3 milliliters, and so that's going to equate to a 6.3 parts per million, which is actually pretty low. You would like it a lot higher than that. But colder water holds more oxygen, warmer water holds less. And so the water that we're standing in right now today is pretty warm. I haven't taken a temperature reading yet, but it's fairly high, and so that's going to be a stress on our organisms that live here. So I just took a temperature reading of the water here. We were talking about dissolved oxygen and colder water holding more dissolved oxygen. The water temperature here is 76 degrees Fahrenheit, and so that's pretty high temperature right now. So it's probably one reason that our dissolved oxygen levels are on the low side right now. The next test we're going to do is a nitrate test. So when we look at plant growth, algae growth within our aquatic ecosystems, we're talking about nitrogen and phosphorus are going to be the two, just like if you're trying to get plants to grow in your garden, is you need to add nitrogen, phosphorus, and potassium. So same thing in an aquatic ecosystem. You hear a lot about the algae blooms. And so your nitrates and your phosphates are going to be what your problems are. Phosphate's the big one, because phosphorus is the most limiting nutrient in an aquatic ecosystem. And just a little bit of phosphorus will throw everything out of control and have all kinds of plant growth. But you also have to have nitrogen, or nitrates. And so I'm going to test your nitrates here with this system. So we're going to get our sample. You don't need a full bottle or anything specific with this. Just enough to grab a sample. Then we have to dilute this sample with some mixed acid. And we're going to add our reagent. This is a test that has to sit for 10 minutes in order to react completely. And so we're going to get everything put in here, we're going to shake it up, and then we're going to wait. Now all these test kits that I'm doing, I want to be real careful that I don't dump any of the waste material back in the stream. We don't want to contribute to any of the pollutants that might be found here. And so I do take all this back and send it through our water system at school. So we're going to invert and mix this until everything's mixed up. Wait 10 minutes to see if it changes color. Usually if there's a lot of nitrates, you'll see a color change immediately. So we may not have any testable nitrates at this point. We are right down the river from the golf course, so you would think that they've been fertilizing. But being that it's later in the summer, maybe they haven't. And so right now our water could test really, really good and not have nitrates in it. But we can look for signs with algae growth, with scum that's growing on the rocks. There is a little bit of nitrate in here, you can tell just from seeing what's on the bottom. So we'll wait 10 minutes and see what we come up with. So we've waited 10 minutes for our nitrate test, and you can see that there really has not been much color change. Very, very faint. So we're probably at less than 0.25 parts per million of nitrate nitrogen. I would say we're not at zero. There is a slight pink tinge to it, but not much at all. So that tells us that right now we don't have a nitrate problem in the creek. But based on the macroinvertebrates we found, we'll be able to compare those numbers when we fill out our score sheet. Okay, so our number one pollutant actually in our waterways in Ohio is actually soil, sediment. And so this is a sediment stick that's going to allow us to determine the turbidity levels, whether we have a sediment problem or not within our streams. If you take a look at the Sandusky River right now, we had a rain the other day, and so there's been a little bit of erosion, a little bit of runoff, and so we do have some sediment in the stream right now, especially up in northwest Ohio with our heavy clay soils. We always tend to have a turbidity problem in our creeks up here. So the way this works is we're basically going to see how much light penetrates through the water column that's in there. So we're going to start by filling our sediment tube. Let's take a sample in case I dump too much out. So what I'm going to do with this tube is I'm going to stare straight down into it, and there's a little black dot on the bottom of this. And I'm going to dump water until I can just see that black dot. And that's going to tell me how many inches of water I can see through to determine my turbidity levels. Probably not going to be a lot today. Down to 14 inches right now. What do you think? Can you still see it?
I cannot.
Cannot. We'll dump a little bit more out. The problem is it's based on what you think you can see. All right, I can see it now.
Yes, barely.
Barely.
No, can't see
Okay,
it.
so right in there. So you can see that we've ended up dumping the majority of the water out. We're at 7 inches. So we have a chart on here. And so if we take a look at our stick in inches, we can see that if we're at 7, that means our total suspended solids is going to be at 52 milligrams per liter. So we can then determine where our water quality is based on that. And I said 54, so that's going to range right in here. We are impaired. So this is an Ohio reference as to do we have excellent water, normal, impaired, or severely impaired, and we are at an impaired stream. But again, we also have to look at the macroinvertebrates. Is this just a one-time thing, or is this pretty normal for this stream here? So there are a lot of different forms you can fill out if you do water quality. This is one that I've modified for my classroom. You can go online to the Ohio Department of Natural Resources, Save Our Streams, Isaac Walton League, all of those different groups, and download the different macroinvertebrate tallies. I combine it with some of the descriptions, physical descriptions, and also then our chemical tests that we take. That way we can compare from year to year our location and also what we found. And so as you take a look in here, we have our turbidity that we've measured, our nitrates, our dissolved oxygen, and our pH. So if you look at some of these numbers, some of them are not the greatest, dissolved oxygen being one that's not real good. And turbidity, because of the rain, is not great right now. But then if we go down here and we look at our macroinvertebrates, the way we score these, we have our group 1s, 2s, and 3s. Group 1s are going to be worth a value of 3 points each because they're only found in good water quality. Group 2 get a value of 2 points each, and Group 1 a value of 1 because they can live wherever. It doesn't really matter what the water is. So we found 3 different types of Group 3 taxa. We found the aquatic worms and planaria, we found pouch snails, and we did find 1 leech. And so our total score for the Group 3 is going to be a 3. Under the Group 2, we found dragonflies, crane flies, and clams. So we end up with 3 different taxa. A value of 2 gives us a total of 6. Now these letters here are just indicative of how many did we find. An A is 1 to 9, a B is 10 to 99, and a C is above 100. That's just an estimate. We don't care if we find 1 or 100 as long as we find 1. But this helps us from year to year to see what we're finding. The Group 1 then, we found the water pennies, the mayflies, caddisflies, riffle beetles, and other snails. And so we found 5 different taxa, times 3 gives us 15. So when I add all of these up, I end up with a cumulative index value of 24, which is really, really good. So you can see here our stream quality assessment is going to be excellent. So based on the score you get, you can get poor, fair, good, or excellent.